All right, we're going to get started. This is Collin Jackson. He's one of the founders of Apportable, and he's going to be giving a talk on diving into cross-platform Objective-C. He's also on leave as a faculty member at Carnegie Mellon University.
Thanks. So I am one of the founders of Apportable, and our mission is to help Objective-C developers build high-quality cross-platform mobile apps. And we have a product called Sprite Builder that I'm going to introduce in this talk. So why would you want to build a cross-platform mobile app? Well, there are really two platforms that are dominating mobile right now. So that's Apple's iOS and the Android platform. There are a lot of different manufacturers that make Android devices. Some of them you may not even know that they're running Android. So for example, Amazon makes tablets that are running Fire OS, but it's still Android under the hood. So if you can cover those two major operating systems, then you can reach the vast majority of mobile app users that are out there. So there are lots of different languages you can use to develop mobile apps. You can develop your app in JavaScript or C#. You can develop your app in C++. Today, I'm going to be talking about Objective-C and why it's a good language to use to build cross-platform apps. So Objective-C is an object-oriented superset of the C language. So how many of you have ever programmed in Objective-C? OK, so I'm seeing about like half the audience. How many of you have ever programmed in C? Like a lot more. So C is a very simpler language. It doesn't support a lot of the object-oriented features of Objective-C. And so Objective-C is adding a bunch of new syntax to C. So why would you want to build your mobile app in Objective-C? Well, you don't have to deal with the overhead of building an app in Java or JavaScript or C#. So when you build an app in one of these languages, your app is going to slow down every time it needs to collect memory because these languages are using a garbage collection algorithm to reclaim unused resources. So that's one reason. There's also some overhead because you're not running your code directly on the processor of the device. Most Android devices are running either Intel or ARM chips, and iOS devices typically are running ARM. So if you want to compile and run directly against that chipset and not have a virtual machine that's getting between you and the processor, choosing language like C, C++, or Objective-C will give you better performance. Another reason why Objective-C is a great language to develop apps is that it has amazing libraries and tools. Apple has poured an incredible amount of time and resources into building xcode. It's a great developer for Mac, a development tool for Mac. And there are a ton of really awesome frameworks that are available to an Objective-C developer to do the heavy lifting of building the app. So you don't have to spend a whole bunch of time writing this library code. You can focus on the high-level behavior that you want to see in your app. So I'm actually going to build an app during this talk, and hopefully my demo will go well. By the time we're done, we're going to have a Angry Birds game that runs on both iOS and Android. So to do it, I'm going to use the Sprite Builder tool, which is a graphical interface builder for Mac that allows you to rapidly prototype and deploy games to both iOS and Android. This is a product that's developed in the open source by Apportable and by other community members. It looks kind of like this, and it's free and open source. It was originally called Cocos Builder, and it's powered by the Cocos 2D iPhone game engine and the Chipmunk physics engine. And many of the contributors to these projects are employed full-time at Apportable working on this. So there's over 75 people that have contributed to this code base. And over 4,000 games have launched using Cocos 2D iPhone. So the icons that I have here are games that launched on both iOS and Android, although a lot of the games are currently iOS only. So I'll talk about why that is. So if you're using Sprite Builder, you don't have to do a lot of the work of building a game engine. You can just focus on the stuff that is unique to your game. And it's easy to extend and customize. So if it doesn't quite have the functionality that you want, Sprite Builder's game engine is open source, and then Sprite Builder, the interface itself, is also open source. So you can add your own plugins or functionality. You can share them with other people. You can upstream them to the project. It handles a lot of the resource packaging for you. So if you have a bunch of different images, it will combine them into one image, which gives you better performance. It makes it easy to target different screen sizes, so you can make a universal app that works on both iOS handsets and also iPads and Android devices. It has an animation editor, so you can set keyframes, and we'll show how to do that. It doesn't force you onto a particular grid. You can place things anywhere you want in the scene. It has a built-in physics engine, so you can have collisions, and we're obviously going to need that for an Angry Birds game. And of course, you're going to want to deploy your app to markets all around the world. So if you want something that works in China, you're going to have to localize it. And there's built-in support for that as well. OK, so I just gave you a big, long list of features, but in order to really understand it, I think we just need to build the app. So I'm going to try to do this on screen, and you can all laugh at me when I mess up. Feel free to interrupt me, by the way, if you have any questions. OK, so I'm going to launch the Sprite Builder tool. You can create a new project using the file new. I already created a new project, so I'm just going to open that up. OK, so this is the main scene that you get when you create a new project. So we're going to start off by creating a level scene to put all of our game stuff into. So that's going to require us to create a new interface file. And I'm going to make the level be a little bit wider than the actual width of the screen, so you can scroll it left and right using your finger. So rather than being 480 by 320, we'll make it 700 pixels wide. OK. So now we have this new level. Now we're going to add the level to the main root scene as a scrolling view. So in the main scene, I'm going to have this scroll view here. And I'm going to set the content node of the scroll view to be level.ccb. So now everything that's in this level is going to be scrollable using my finger. So I've already got some images that I've added to this project. I'll show you how I added them. It's really easy. So you go to create a new folder called sprites. And then just go look up any images that you have on your computer. And I just created a few images for this game that we're going to build. So I just take these and drag them directly into the Sprite Builder editor. OK, so now we're going to start adding those elements to our game. We'll probably want to start off with some kind of background. So let's drag this background into the level. And now we have some sky. OK, so we're going to want some physics in this game. So we're going to need gravity. And if there's gravity, there needs to be ground, because otherwise you're just going to fall forever. So let's add some ground to the scene. And let's add a few things for us to knock over. So maybe we'll add some shapes. I want some sort of flat thing. And OK, so now we've got a tower that we can knock over and convince ourselves that the physics are working. OK, so if I click this wrench right now, it's going to create an xcode project for us. And you can see it's publishing all the resources. And then you can go find the xcode project here. It's created alongside your Crocus Builder project. So you hit play, and it's going to go ahead and show that scene on your device. Now I'm designing for a handset right now, so I'm going to run it in the iPhone simulator. Okay, so one thing that we can notice, let me change the device here to iPhone Retina. One thing you can notice is that the gravity doesn't seem to really be working. Everything's just kind of floating there in the air. So we need to add physics to this game. So the way that you add physics in Cocos Builder is you go and you go to the level that you want to have physics in, and you add. So you switch over to this the square to add things to the scene, and you add a physics node. And everything that you want to be involved in physics, you need to. Sorry, I think I added a scroll view. Physics node. So everything that you want to participate in the physics of the scene, you add as a child of the physics node. So I'm adding the ground as a child. I'm adding these shapes. The background, I'm not so interested in having that be part of the physics, so I'll just leave it by itself. So now everything's a child of the physics node. And the physics node can have its own gravity. So we'll set gravity to be negative 100. OK. So the background somehow got in front of everybody else. Let me move that up. OK. So now we have gravity. And we're going to want to set different physical properties of the items in the scene. So this ground, for example, we want to make it not able to move. So the ground is static. But these other items that are in the scene, we want them to be dynamic so that they can be knocked over and they can fall and all that good stuff. OK, so now those items that are in the scene, they all have physics enabled. And we're going to go see if we can have a more interesting scene. So let's launch this app in Xcode again. And voila, you saw everything kind of snap together when gravity hit it. OK, so we want to knock over this stuff. So we're going to throw some birds at it. So to do that, what I'm going to do is I'm going to create a new interface file for the birds. And the birds are going to have their own physics. And so they have their own image that's associated with them, so I'm going to make them inherit from a sprite. OK, so the sprite has an image that's going to be this bird. And the physics, when I enable that, I'm actually, instead of using the polygon, we're going to have a circle that sort of snaps around the edges of the bird. OK, so we could throw this bird directly into the scene, but I think it'd be more interesting if the birds can be created by the user tapping on something. So let's add a button to the game that's going to be able to shoot birds. So you can just drag this from the components doc on the left. So rather than have this be a button that has words on it, let's get rid of the words and have it be an image button instead. I'm going to make it 120 pixels by 100 pixels. And I've already got a button image here that I think will be good. So it looks like that. And then when you put your finger on it and press it, the image will also be the same. OK, so now we have this launcher in our scene. And I think that doesn't really look like something you'd launch birds out of. So let's add something else to it that the birds can shoot out of. So I'm going to add one more sprite, which is this arrow thing. All right, so that looks like a cannon. You could really shoot birds out of that. And I need to make sure that everything is part of our physics. Actually, this doesn't need to be part of physics. But it looks like it wants to be behind the button. There we go. OK, so you can rotate things around an anchor point. I'm going to move the anchor point to the bottom of this cannon so that when it rotates, it's going to rotate around that point. And let's give it some initial rotation so we'll actually hit the thing. All right, now we're ready to do some serious damage. So far I haven't written any code. This has been entirely in the editor. I think we're reaching the limits of what we can do without writing any code. So I'm going to start defining a behavior for what happens when you press this button. So to do that, I go to this code connections tab right here. And we're going to say that when this button is pressed, it's going to invoke the method called launchBird. So this is the way that you express methods in Objective-C. They have a colon at the end of the method name. And if there's multiple arguments, then each argument is described with a colon after it. So we need to invoke this method on an object. What object do we want to invoke the method on? Let's invoke it on the document root. So basically, this level that we're in right now, we'll call the launchBird method of the level. So to do that, I need to actually create a level class. By default, the scene doesn't have a custom class associated with it. So I'm going to click on this node that's the root class of the scene, and I'm going to give it a name level. OK, so we're getting there. I'm going to publish this to Xcode, and we're going to have to write a little bit of code in Xcode now. So I need to create a new class. So I'll say new file. It's an Objective-C class, and it's called level. And we'll just put that in the source directory. OK, so now I have a level.m and a level.h. .m is the extension that Objective-C uses. And .h is the header file that describes the class. So I just said that I was going to add a selector called launchBird. So I'm going to show you how you write a method in Objective-C. So this method is not going to return anything, but it's called launchBird. It takes one argument, and the argument is actually the button that was pressed, but we're not going to use that for anything. So let's find out whether or not we've wired this up correctly by just logging something to the console. So in Objective-C, you can call methods just like you can in C, functions like you can in C. But if you want to get a Objective-C string as opposed to a basic C string, you put this little @ sign at the beginning of your strings. So if this works, this will log this to the console. OK, so I saved everything, published it, and let's see when we click this whether it actually is noticing that I've clicked. OK, so it's complaining about something. It's probably complaining that the selector was not recognized. OK, so I need to make sure that this custom class thing got set correctly. And it looks like it didn't, so let me save that again. OK. And there you go. So you can see down here in the console, when I click the button, it says I've launched the bird. So logging is useful for knowing that we didn't totally mess up, but we really want to launch the bird. So let's show how to actually do that in Objective-C. So I need to start off by getting a reference to a new bird. So we're going to create a bird. So birds are nodes. So I'm going to create a CC node. And I'm going to use this CCBReader class to actually instantiate the bird from file. So we're going to pass in the name of the CCB. Remember when we created this interface file? So this is now going to be able to pick up this bird file that we've created. So when you create a node, that's nice, but you really need to add it to the scene before the user can see it. So to do that, we're going to need to get a reference to the scene in order to add the node as a child. We're also going to need to get a reference to the button in order to place the bird close to the button. So those are two things that Sprite Builder can give us if we ask for it. So let me point out a little bit more syntax here. So what am I doing here with these square brackets? So CCBReader is a static. CCBReader is a class. But when you do things this way, and you actually send a message to a class, so that this square bracket notation indicates that you're sending the message nodegraph from file to this class, and you're passing in the string bird as an argument. So CCBReader class knows how to respond to that method by creating a bird and then passing it to us so that we can call methods on this, this bird. Maybe I'll call it bird. So if you have written code in C, you might be wondering, when is this bird ever going to get deallocated? You just created some memory, and how do you know that it's not just going to leak? And eventually, the device will run out of memory. So in Objective-C, objects have a reference count. And so it's keeping track of the fact that this object, whether anyone was actually using the bird for anything. And if I were to not use the bird at all in the rest of this method, it would get deallocated automatically when we got to the end of the the method, and the auto release pool was drained. So that's something that gets inserted by the compiler. But in this case, when we add the bird to the scene, it'll create a new reference to the bird. And so the bird is actually going to stay around longer past the end of this function. And it'll be automatically deallocated when it is no longer a child of anything in the scene. OK, so let's go ahead and add the bird to the scene now. Now, I need to get a reference to the scene so I can add the bird to it. And I'm going to show you how to do that. So this physics node, we can assign it as a variable on the level scene. So we're going to put an underscore there because it's going to be a private member variable of this level. And we also need to make sure that we know how to get to the launcher. I guess we want the cannon, really, so that we know where to put the bird. So let's give the cannon something that's launcher. OK. So now that I've published those two things, the physics node and the launcher, now that I published those two things, I can access them in Objective-C as long as I declare them in the header file of the class. So we have the launcher and the physics node of the scene. OK, so because I've declared those things in the header file of the class, I can access them only in the implementation. They're not accessible to any other class. It's private data. So we're going to add the bird to the scene. So the physics node I forgot the underscore. See, xcode is really great because it tells you that you're doing something wrong if it can't find the variable that you're using. OK. So now it knows what I'm doing. So I'm going to add child bird. So now the bird exists in the scene that we have created. But it doesn't have any reasonable position, and it doesn't have a velocity. So it's not really going to go anywhere. So we need to give it some position. So let's initially just give it the launcher position. And it needs some velocity, so let's apply some force to it. Body. All right, so let's give that bird some force. All right, so it's complaining to me that that I forgot the underscore again. I like xcode. So here's the moment of truth. Let's see whether or not it actually shoots a bird. Whoa. OK, so one thing you might have noticed is when it hit that triangle, it actually knocked it over before it got to the triangle. Why do you think it did that? There's a bounding box around it, exactly. So we need to actually adjust the bounding box. It'll probably do this automatically in a future version of Sprite Builder, but for now, we have to adjust that manually. OK. So now we can shoot birds. But I feel like there's not a lot of strategy in this game right now. There's really only one button to press, and you don't have any choices that you can make. So what I'd like to propose is that let's have the cannon sort of move up and down, and then when we launch the bird, we'll have some choice as to what direction the bird is going when it flies out. So to do that, I'm going to have to show you how the animation editor works. So let's go to this arrow, and we're going to have it move between two different keyframes. So let's start by rotating it up to the sort of highest position that you might want to shoot. And then I'm going to set a keyframe. And then we're going to move over to the sort of lowest position that you might want to shoot and set another keyframe. And we're looking for a 2-second duration here. And then finally, we'll set a keyframe back at the top. OK? And then this animation, we're going to chain it to itself, so it'll just keep going. when it gets to the end. All right. So if that works, we should see the cannon move up and down. There it goes. Okay. So, however, when I shoot birds, they all keep going the same direction that they were going before. So we need to actually decide what direction to shoot the bird based on the direction the launcher is pointing. So to do that, let's decide what the direction of the launcher is. So to do that, I'm going to first figure out what is the angle of the launcher. So this is going to be something that we can figure out by asking the launcher what its rotation is. And then I'm going to create a vector, which is the direction vector, and that's going to be a combination of the sine of the angle and the cosine of the angle. Okay, so now I have this direction vector, and rather than just applying force kind of in a standard 45-degree angle, I'm going to actually take this direction vector and multiply it by this 50 million force. So let's use the convenience function for that. Oh, now we're going to be pointing the bird in the right direction. Let's see if I did that right. Uh-oh. It seems like birds are not going in the direction that we were hoping. Okay, so what am I doing wrong here? I'm converting from radians to degrees. I wanted to do the other way around. Ha! All right, that seems to be vaguely working. I noticed that there seems to be a little bit of lag of the bird coming out of the cannon because it's actually getting started at the anchor point of the cannon. We kind of want the bird to come out a little bit further out. So let's, instead of setting the initial position of the bird to be the position of the launcher, let's instead have the bird be a little bit further out. So I'm going to say let's add to the launcher position the direction multiplied by, like, say, 100. Yeah, that looks. Yeah, that was probably a little too much. Let's try 50. You can see I'm iterating really fast. There we go. So now the birds seem to really be coming out of the cannon. All right, well, so we just built Angry Birds in like 20 minutes. It's pretty awesome. So I promised you a cross-platform app, and so far I've only been showing you things in the iPhone simulator, so you should not believe me when I say that this Objective-C app is going to run on Android. So let's go back to my slides for a sec. So in order to get this Objective-C app to Android, we're going to have to invoke the Apportable compiler. The Apportable compiler is available for free on the Apportable website, and it cross-compiles Objective-C source code to Android. So I'm going to prove it to you on this Android device, and then I'm going to explain what is actually happening. So I'm in the directory of the project that we just created, and I'm going to run the Apportable compiler. I'm going to say Apportable load. So what this is doing is it's scanning the xcode project to pick up all of the project file information, and then it's compiling the files of our project into an Android APK installer. So it takes about 20 seconds to build it, and then another 10 seconds or so to transfer to the device. So this is something that you probably wouldn't want to do on every build. If you're trying to iterate really quickly on your app, you might want to spend most of your time in the iPhone simulator. But in order to know whether or not it really works, you would want to see it running on a real physical Android device. So let's see if I can. This isn't connected. Saying that I can't find this Android device. This is one of the problems with Android devices. They're really finicky to debug. And testing it in the Android simulator is not really as good as testing it on a real device because there are a lot of bugs that you won't actually see until you try it on a real hardware. So I think I'm going to try uploading this APK to our server instead because this USB cable is not working. I can load it in the web browser. I need to get on the Wi-Fi here. Yes. I agree. Okay, great. Email is a required field. You all know my email address. Oh, that's not my last name. Hey, okay, great. Thanks for your patience. Okay, so once you're on the Wi-Fi, this is really fast. you can see why most developers like to develop in the simulator for as long as humanly possible. But you do want to test on a real device. So it's upside down, but there you can see. OK, cool. So now we have our app running 60 frames a second on Android. Very realistic physics. OK, so that was cool. What did I just do? We took the client compiler. It's the same compiler that's used by Apple to build iOS apps, and we modified it to support Android. We added in support for all the advanced stuff that you can do in Objective-C, like automatic reference counting and Objective-C literals, and made a compiler that can compile pretty much any iOS game that you might want to write. It can also compile some other types of apps as well. What's cool here is that you're building a truly native app. So the Objective-C source code is getting compiled directly down to an ARM binary that runs directly in the processor. There's no overhead at all from Java, HTML5, JavaScript. Any of those intermediate languages that get between you and the bare metal are not present in this app. So you're really getting the maximum performance, which is what a game developer would care about. If you do want to call into Java, we have an API for that. It's called BridgeKit. And it enables you to take any Android class or any custom class that you wrote in Java and invoke it from Objective-C just by calling it like a regular Objective-C method. When you develop an app, you're probably going to start off by making a really great app in the simulator. But when you get to Android, there's a few considerations that you're going to want to pay special attention to. So as you probably noticed by looking at the demo, the screen size of this Android device does not actually match the screen size of an iPhone. And so things kind of fell off the edge of the world because you could see more than you were supposed to. So we actually have an API that allows you to emulate any iOS screen size if you want. Or you can actually build your app to scale to arbitrary screen sizes. And Sprite Builder lets you do that as well. Another thing that you might want to do when you're thinking about Android is supporting the hardware back button. So Android devices, they have this back button, and it's an integral part of the Android experience. You can always press back, and something reasonable has to happen. If the app crashes when you press back, or if nothing happens, users will get really mad, and Google will refuse to feature the app. So don't ever do that. So we have an Objective-C API that allows you to gracefully handle those back button presses and do something reasonable in the game, like bring up a pause menu or dismiss a dialog that's on the screen. You can also debug your app. So I showed you debugging in xcode, but you can actually use the command line debugger to set breakpoints, invoke Objective-C messages, do anything you want to do in order to understand the behavior of your app using the Apportable compiler as well. So this is a new development. Objective-C has been around for decades. It was part of the Next company before it was acquired by Apple. And it's probably still the most popular language for developing mobile apps. But until today, it wasn't really a cross-platform option. And if you want to support Android, which is the most popular OS by number of users, it was an off-limits language to you. But now you can build apps on iOS using only free open source tools, and you can still get to Android using the Apportable compiler. So I think this is really going to be something that large game studios will consider when they're trying to decide which game engine that they want to develop their next app on. And it's not something that can only be used for games. You can also cross-compile other apps like music apps, photo sharing apps, and any other app that really cares a lot about performance. So I've been talking for 45 minutes. I thought maybe I'd open it up for questions before I go any further. Yeah? Yeah, so the Apportable compiler includes a library implementation of most of the iOS frameworks that game developers use. And that includes both the ones that ship with iOS, like UIKit, and the frameworks that are third-party frameworks that you might want, like the Facebook SDK or Parse SDK. However, if you're using an SDK that's really out there and isn't implemented in the Apportable compiler, for example, using the new text APIs in iOS 7, then that might not yet work with our system. So you'd have to wait for the Apportable compiler to catch up. And to date, we've been mostly focused on APIs that matter to game developers, because that's 70% of the mobile apps that are out there. Yeah?
You declared in your interface file instance variables, I think.
You also do properties. Yeah, so you could definitely do properties, and let me show you what that would look like. So, so this is how you declare a instance variable, but you can say @property cc node launcher. You can bind it to a private variable, I believe. This is a yeah. So then if you were to try to access the launcher here, instead of saying underbar launcher, you could say self.launcher. And this dot notation is, let's see if that actually works. Oh, I was synthesizing it wrong, that's why. So let me show you how you declare that properly. So the way we do it is you say synthesize launcher equals underscore launcher. So that's how you bind a property to a private member variable. So now this should work. So it's the same behavior, but now we're exposing this launcher as a public property. So if somebody else had a reference to the level, they would be able to get access to the launcher just by calling the launcher method. And there's kind of an interesting syntax here. So you can see you can actually access the launcher by saying self.launcher, and that's equivalent to saying self-launcher. So I showed you before how to invoke a static method of a class, but we actually have an invocation here on the physics node of a member method. So the addChild is a method that we're invoking on the physics node, and you can also invoke methods on yourself. So this would be calling the launcher method. So a property is just a getter method. And using the dot notation is equivalent to just calling a method with no arguments. So I didn't really give a complete tutorial of everything you can do with Objective-C. It would be really hard to do that in an hour. But there's a lot of really cool language features that you should check out. If you get into more advanced development, there's some really cool APIs like core data that allow you to do to serialize all of the state of your game and send it to the server. Something that obviously a lot of developers are doing now. They're not building just local games, but also games that have state that's out there in the cloud. So it's really easy to do that using Sprite Builder and Apportable compiler. Any other questions? Yeah.
I was just wondering, is Apportable?
Yeah, absolutely. Yeah. So the Sprite Builder is a game engine that is chipmunk-based, but you can compile any Objective-C game that you want with the Apportable compiler. We just happen to demonstrate that on the Sprite Builder engine. But if you use the Box2D engine, then it will work great with Apportable as well. And that is what a lot of game developers are using. I can tell you a little bit more about my company. So Apportable was started in 2011 through the Y Combinator technology accelerator. I started it while I was in the faculty at Carnegie Mellon University, and I was frustrated that I couldn't play Angry Birds on my Android device. And so I started calling up the developers and demanding that they support my device. And they said, well, we wrote the game in Objective-C. Sorry, we have a team working on the Java version. It'll be 6 to 9 months. It wasn't a very satisfying answer, and so I, didn't did what hackers do and just built a compiler to solve their problem. It took me a lot longer than I thought. We have about 50 people on our team now, and most of them are engineers that are working on building out support for all the different Objective-C frameworks. But it's something that a lot of developers really care a lot about, is supporting multiple platforms at launch and really having a high-quality Android app that will be featured by Google and make lots of money. Any other questions? OK, well, I think I'll wrap it up there. But if you would like to talk to me more or see some more demos, I'll just be here, and we can hack on the app some more together.